Good afternoon, class. Here's chapter 3, derivatives, section 3.5, the chain rule. We're looking at the second part, implicit differentiation. We covered derivatives and rates of change, the derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rule, and now we're going to look at the implicit differentiation. Reminding everyone of various differentiation formulas, starting with the definition, dy dx is the limit of delta y over delta x as delta x approaches 0 in Leibniz's notation, or f prime of x equals the limit of f of x plus h minus f of x over h as h approaches 0. Definition. Then we look at some theorems. For example, if you are taking the derivative of c times f of x, you can take the c out. If you're taking the derivative of a sum is the sum of the derivatives and so on. In essence, they refer to the fact that you can do them term by term. The power rule, the derivative of x to the power of n is n x to the power of n minus 1. The derivative of a constant, any number is 0, and therefore kx is k. And they are trigonometric functions. The derivative of sine is cosine is negative sine, tan is secant squared. The derivative of cotangent is negative cosecant squared, secant is secant tan, and cosecant is negative cosecant cotangent. Then we have other rules, for example, the product rule and the quotient rule. And in a shorthand notation, f g prime is f prime g plus g prime f over g prime is f prime g minus g prime f over g squared. Composite function y equals f of g or f of g of x gives us the chain rule. The derivative of that is f prime of g of x times g prime of x. For an extended power rule, the derivative of g of x to the power of n is n g of x to the power of n minus 1 g prime of x. And this is Leibniz's notation. dy dx is dy du times du dx. We define E in various formats. One of them, E is the limit of 1 plus 1 over n to the power of n as n approaches infinity. Or the second format is a number such that the limit of e to the power of h minus 1 over h as h approaches 0 equals 1. And the derivative of any exponential function starts with itself, meaning if it's e to the power of x, the answer is itself. If it's e to the power of kx, the answer is itself by times k by the chain rule. E to the power of g of x is itself times g prime, again by the chain rule. And if it's b to the power of f of x, the answer is itself. Times ln b, this is by logarithmic properties, times f prime of x by the chain rule. So these are differentiation formulas. And now, section 3.5, the chain rule, and more specifically, implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. For example, we say y equals x squared minus 2x plus 1, or in general, y is f of x. We've dealt with them, we have differentiated them, no problem. However, some functions are defined implicitly by relation between x and y, such as x squared plus y squared equals 25, or x cubed plus y cubed equals 6xy. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x and then solving the resulting equation for y prime or dy dx. Here's a warm-up example to get us started. We want to differentiate 4x plus 2y equals 10, two different ways, explicitly meaning solve for y. So we're going to start, because it's easily solved for y, we're going to go with the explicit format first. So that means I'm going to move the 4x and make a negative on the right side. So 4x plus 2y equals 10 becomes 2y equals minus 4x plus 10. I'm going to divide everything by 2. y becomes negative 2x plus 5, and therefore y prime is simply negative 2. So explicitly, we came up with the answer because it was easy to solve for y. Let's do it implicitly, which means we are going to differentiate each one as it occurs. For example, obviously 4x is 4, but what about 2y? I'm going to remind you that y is a function of x. Y is like g of x. The derivative of g of x is g prime. So the derivative of y is either y prime or just write dy dx. Makes no difference. I'm going to go with both methods. So this one is 4. This one is 2 y prime or dy dx. And any number results in 0 when you differentiate it. With respect to any variable makes no difference. I'm going to move the 4, make it negative on the right side. I'm going to divide both sides by 2. dy dx or y prime equals negative 2. These are different formats of writing them. The advantage of dy dx is that it's telling the reader the independent variable must be x. It's given as x. Given the circle x squared plus y squared equals 25, find y prime. Reminding you that equation of a circle centered at 0 is 0. It's x squared plus y squared equals r squared. Therefore, this is a circle with a radius 5, centered at 0, 0. If it's located at a different center, hk in general, x minus h quantity squared plus y minus k quantity squared equals r squared. I hope you remember this. I've gone over that already. So we are going to differentiate this. So let's differentiate both sides. And that's the concept of implicit differentiation. Obviously, x squared, we have no problem, and we know the answer is 2x. What about y squared? Remember, y is g of x. So what is the derivative of g of x to the power of n? N, g of x to the power of n minus 1, g prime of x. Therefore, what is the derivative of y to the power of n? Is n, y to the power of n minus 1, y prime. Therefore, this is 2x. This is 2y, y prime, and 25 is a number. Its derivative is 0. Because we want to solve for y prime, we're going to move the 2x and make it negative on the right side. Divide both sides by 2y and simplify, and y prime becomes negative x over y. Find an equation of a tangent line to the circle at the point 3, comma 4. So we have x equals 3, y equals 4. We have the pair. What is missing? The slope. Therefore, here's the derivative. If I plug in 3 and 4, that gives me the slope at the given pair or point. So we're going to go with y minus y1 equals m times x minus x of 1. That's the point slope. So y minus 4 equals m negative 3/4 times x minus 3. We're going to distribute. We get negative 3/4 x plus 9 over 4. If I move this, 4 is positive 4, or 16 over 4, and y becomes negative 3/4 x plus 25 over 4. This is the equation of a tangent line, everybody. Find dy dx or y prime where x cubed plus y cubed is 6x times y. And we start with this. Obviously, that's simple, 3x squared. And y cubed is following that 3y squared dy dx. On the right side, it's the product of 6x times y. So I'm going to put a raised dot here. And on the right side, I'm going to call it f times g. Now we are ready to move on. So again, x cubed, 3x squared. Y cubed, according to this, just like an extended power rule, 3y squared dy dx. At the right side, as I mentioned, it's f times g. So f prime is 6 times g, which is y, plus g prime, which is y prime or dy dx. Since we use dy dx, we're going to go with dy dx, times f, which is simply 6x. And this, and I'm going to put an asterisk next to it, this is the only calculus step. Of course, we are not done. We are solving for dy dx. Therefore, we're going to move things around such that dy dx are next to each other. In other words, this one we keep it, this one we move, make it minus 6x dy dx. This one we move, we make it minus 3x squared. So this comes this way, becomes minus 6x dy dx. This comes this way, becomes minus 3x squared. And on the left side, we want to solve for dy dx. We want to factor the dy dx out. We notice there's also a factor of 3. So if I take the dy dx out as well as 3, this gives me y squared, and this one gives me negative 2x. The right side also has a common factor of 3. So I'm going to say 3 times 2y minus x squared. This way, you can just drop the common factor of 3. And if you divide the left and the right by y squared minus 2x, you get dy dx equals the right side 2y minus x squared over the coefficient of dy dx, which is y squared minus tx, minus 2x. Find dy dx or y prime where we have 4x squared y plus 2y squared plus 18. And right away over here, we notice is the product of 4x squared and y. So we put a raised dot in between. And we say this is f times g, which means again, we are going to use the product rule. So starting with this, f prime is simply 8x times g, which is y, plus g prime, it's just y prime or dy dx, times f, which is 4x squared, 2y squared, just the extended power rule gives you 4y prime. The right side is a number. Any number results in 0 when you differentiate. Since we are solving for y prime, we're going to keep these two and we're going to move this one. Now, when we keep these two, not only we can take the common factor of y prime, also 4 out, so we get 4y prime times what? X squared plus y. Then 8xy becomes negative 8xy on the right side. We are going to divide both sides by whatever is sitting next to y prime, which is 4 times x squared plus y. 4 goes away. This changes to negative 2. So y prime is negative 2xy over x squared plus y as the final answer. Let's work on this. 4x squared plus 6y plus y squared equals e. Let's differentiate term by term. 4x squared, 8x, plus 6y plus 6y prime, plus y squared plus 2y prime. E, any number, results in 0. Remember, E is a number, everybody. And it's important to understand whether you have E or pi or 10 or any number, the result is 0. So having said that, we are done with calculus. We're going to solve for y prime, which means we're going to put these two together because they have the y prime. So if I take the y prime out, also we notice 2 is in common, so I'm going to take 2 y prime out. If I take the 2 y prime out, this gives me 3, this gives me y. What about 8x? Move it, make it negative 8x on the right side. So right away we can drop the 2 and change this one to minus 4x. Divide by 3 plus y, and y prime becomes minus 4x over 3 plus y as the final answer for this case. All right, we want to find dy dx or y prime, where x times e to the power of y plus 2y cubed equals 3x. Clearly, this is the product of x and e to the power of y. We put a raised dot in between, and we call it f times g. We're going to use the product rule. So x gives you 1 times g e to the power of y, g or e to the power of y. Any exponential, you start with itself, and then times y prime, because y is a function of x. So that's using the chain rule. So e to the power of y times y prime, that's g prime. Now f is x, and this is f prime g plus g prime f. 2y cubed, you just follow that, and you get 6y squared y prime. 3x simply gives you 3. And I put the asterisk next to it. This is the only calculus step, everybody. Now, to finish it, use our algebraic techniques to solve for y prime or dy dx. So we put these two together, and let me erase my work. So right here, we want to solve for y prime. We're going to factor the y prime out. So this gives us x times e to the power of y. This gives us 6y squared. This is just e to the power of y. Move it and make it negative on the right side. So what is y prime? The right side divided by the coefficient of y prime. Y prime becomes 3 e to the power minus e 3 minus e to the power of y, x e to the power of y plus 6y squared as the final answer. Find an equation of a tangent line to x squared y squared equals 1 at negative 1 comma 1. So in order to find any line, we need two things. We need a pair and we need the slope. To find the slope, we need to differentiate this. To differentiate this, we recognize this as the product of x squared and y squared. So we put a raised dot in between, and we call it f times g. And we're going to use the product rule on that. So f prime is simply 2x times g y squared plus g prime 2y prime 2y prime times f, which is x squared, right side 1, you differentiate, you get 0. And this is, believe it or not, the only calculus step. Now we're going to solve for y prime, which means we are going to move this and make it negative on the right side, minus 2x y squared. We are going to divide everything, that means both sides, by whatever is sitting next to y prime. In other words, divide both sides by 2yx squared. So the left side remains with y prime only. Notice we can cancel out the 2. We can cancel out the y with the exponent at top. We can cancel out the x with the exponent at the bottom. And therefore, y prime is simply negative y over x. You want the slope, you have to plug in. So we're going to write m equals minus y over x evaluated at the pair negative 1 comma 1. So what happens? If I replace the x with negative 1, the bottom is negative 1. If I replace the y with positive 1, I get minus and then positive 1. So minus 1 over minus 1 is positive 1. So it's just that. And now the point slope gives us y minus y1 equals m times x minus x sub 1. So y minus 1 equals m, which is 1. X minus 1 means x plus 1. Therefore, this is x plus 1. We add another 1 because negative 1 moves. And the final answer becomes y equals x plus 2. So the equation of a tangent line to x squared y squared equals 1 at negative 1 comma 1 has the equation y equals x plus 2.